Okay, in this video, we're going to look at difference of squares. All right, so if I'm given a quadratic equation and I'm only given ax squared minus c, well, I'm missing the b term. I don't know what the b term is, but that doesn't mean that I still can't factor it. If I recognize that both the two terms that are there, ax squared and c, are perfect squares, then that means that I can take the square root of them. And so unlike a perfect square, factoring using the perfect squares method, the difference of squares, you're actually subtracting two squares, which means that you're looking for your middle term to cancel out. So notice here that we have a and c, but we don't have b. Well, that happens is because they cancel out. So if I look at kind of the general form, if ax squared is a perfect square and c is a perfect square, well then if I take the square root of both of them and set the factors as opposites, so for instance, the square root of, this will be the square root of ax squared times the square root of c, and then the other one would be negative square root of ax squared times the square root of c. Well, what's going to happen is both of these will cancel out. Okay, so both of these terms will cancel out when I try to add them together. So that's what happens with a perfect square. So maybe all of that doesn't make sense to you. Let's look at some simple numbers. Let's take the square root of x squared. Well, that's x and x. And now let's take the square root of 25. Okay, that's 5 and 5. Well, I'm going to have two binomials, and so x and x will be factors. 5 and 5 will be factors. But of course, for the middle term to come out, to cancel out, that means that one of the terms has to be negative and one has to be positive. So I have x plus 5 and x minus 5, and that should be equal to 0. Well, let's check it. Well, here's the outside terms, negative 5x. Inside terms, positive 5x. Well, a negative 5x and a positive 5x will cancel to 0, and so I would only be left with the outer two terms, okay, the first and the third term. So in that case, x plus 5 equals 0. Remember, I continue solving to find out where it crosses the x-axis. And then x minus 5 equals 0. And so, of course, one root will be at x is equal to negative 5. The other root will be at x is equal to positive 5. So instead of the squares being the same number, the squares are actually opposites. Okay, so these are my solutions to the factors. And, of course, I need to put those back into the equation and check. I should always do that. Okay, so now let's look at 4x squared minus 9. Okay, let's factor this one. 4x squared factors down into 2x and 2x. Remember, they have to be perfect squares. Okay, so you can't split up 4x and x. You can't do that. It has to be 2x and 2x if it's a difference of squares or perfect squares. Okay, so then I have 3 and 3. So now let's break it up. 2x and 2x. And then, of course, 3 and 3. And in order for the middle terms to cancel out, one has to be positive and one has to be negative. Okay, so in this case, I get positive 6x and negative 6x, which will cancel to 0. So now let's continue solving for x. 2x plus 3 equals 0. Oops, didn't mean to do that. Okay, 2x plus 3 equals 0. And then 2x minus 3 equals 0. And so in this case, x is equal to negative 3 halves, and x is equal to positive 3 halves. All right, so I hope this video has been helpful to you, and you can go back and watch it as many times as you need to in order to go back and look at differences of squares and solving quadratic equations. Thank you, and catch the next video, which we will talk about solving using the greatest common factor method.